So I've been giving a lot of thought to tokens and token programmability on Bitcoin recently. And between some clients and some people I work with in other areas and Degan from BA, and there's just been a lot of discussions about kind of tokens and token protocols. And where my brain has really been going is on programmability of those tokens. So we have with BSV21, there is some programmability that has already been implemented and supported, but there's also some limitations that Bitcoin script really is not well suited for parsing JSON. And BSV21 is very much kind of a simple, human readable, it's not built for computers, it's not built for programming, it's built for prototyping and seeing and figuring it out and being able to know what's going on. So I want to kind of talk through first. Here's the kind of the model for programming BSV21. Like what you can do is you can write contracts that will hold on to some BSV21 tokens and issue some BSV21 tokens. So it can do that part just fine. So but it's very big. Just the contracts themselves are very big. There's got to be code in there to build JSON, and so it leads to very, very large contracts. The other kind of limit to programmability of BSV21 is because the body is JSON, like I said, you can't really parse it in Bitcoin script, which limits the amount of programmability you can do with it. So I've been really thinking about kind of bringing like a token primitive that other things can be built on top of to really allow full programmability. And that is a couple basic things. One, it needs to not be in JSON. It needs to be easily parsable by Bitcoin script. And two, some of the limitations we've had with BSV21 are essentially it is from the get-go you deploy the entire supply and that's it. That's all there will ever be. And so if you want to have some sort of a ongoing issuance, you need to issue a huge supply and lock it up in some way such that it behaves as a vault. And then that vault can pay out while it's got finite supply left. When that supply is done, the token's gone. So you can't really have high turnover issuance, reissuance, all that kind of stuff. So I've kind of stolen some ideas of what I'm going to talk through here from Degan, but kind of brought it down to, I say I stole it from him. He also, I'm sure, was inspired with BSV21. So it's a big collaborative thing. But essentially, this is not a release of a new token standard or anything. This is literally me thinking through things. And so this might end up be something that collaborates back with Degan. This might be something that doesn't go anywhere other than a thought process, but I wanted to break down just kind of a very, very basic kind of primitive token protocol. And so I'm, for the sake of this exercise, just calling it shrug token, which uses the shrug emoji as kind of a protocol identifier because it's mine. So essentially, there's only 6 script elements that get used for this protocol. So the first one is always the first thing in the locking script is a protocol identifier. Right now, as I said, it's the shrug. Where this goes, who knows what that will be. Then we've got second, the concept of a token ID. And the token ID is the out point where this token is deployed on chain. So if we are deploying a token, you simply leave it false. If it's a child of a token, if it's an instance of a token that's already deployed, the out point where the output that had the false was on the chain is what you use for that token ID. So those two things get out of the stack, and then we just drop them right off the stack. So that's kind of the header of the token. It's just these, a protocol identifier and a token ID. And then we have two more fields. So I have what I'm calling right now a mint permission or a super permission or an admin permission or something. So essentially an output can either be just a token, in which case, or an out point of tokens. It's not a single token, it's however many tokens are in it. And so if it's false, it just holds tokens. And if it's true, it is a key to be able to do some managed properties on this token, such as issuing new tokens or whatever else. Burning existing supply, reissuing supply. There's other things that can be done with that in the future, but I don't want to get things too crazy right now. So essentially, we have an output of, is this just a token or is this a mint? And then finally, we have one more data push that in the case of it not being a mint, if it's just a token, then what we store there is the amount that exists in that output. So we're storing this as a Bitcoin encoded number, so there isn't really a limit to the size or precision. And then if it is a mint, that field becomes kind of a arbitrary data repository for whatever token protocols get built on top of this. They can use that for identifying symbols or icons or rules or whatever else. So this, I'm shooting for very, very basic primitives of a token protocol. Everything else gets layered on top of it by users, by applications that come. We drop those things off the stack, and then we have a locking script, which can be any locking script. So this kind of prefix to your output script can be used with any other locking script you want. So then here's just kind of some illustration of the transactions themselves. So to deploy a fixed supply of a token, you write an output that has false for the token ID, and then false for having the mint permission. And then you specify the supply. So just by writing a transaction output that has those 6 push opcodes on them, this token is defined with a supply of the value that's pushed in supply. And to transfer those things, it's simply a matter of having your token outputs that have been previously deployed or transferred as an input. And then we write the same outputs where we've got the shrug, we've got the token ID now, which is the out point where this transaction actually exists on chain, or this output, I should say. So this is just that value. And these are not mints, these are just tokens. And here's how many tokens each output gets. So that's for a fixed supply token. There really is not much to it. You have one deploy and everything else just uses, and all the transfer rules are BSV21 transfer rules. So it basically means the total sum of the tokens that are transferred in here has to be greater than or equal to the amount of tokens that come out. I think that's pretty much it. I mean, there's a lot more of that in the code than that in the code, but as far as validation rules, yeah, the amounts need to work out. It's just a simple UTXO system. All the actual Bitcoin validation will happen in the locking scripts that come after. Okay, so that's a fixed supply token. So for a managed token, when I first deploy it, rather than passing a false and a supply here, we're going to go with a true and our arbitrary data. So again, I've got false for a token ID. So this is a new deploy of a token. Dog's having a sneezing attack out there. And then this is an admin token, or this it has the mint permission, and then here's whatever data we want there. So this would be where, yeah, if you wanted to have a system that has icons and symbols and legal disclaimers or whatever, that goes in there. And that's it. So that output then becomes not a token output, but a mint output. And so mint outputs can create new tokens. So you just spend it in a transaction that then creates token outputs that are not mints, they're tokens. Or it can also create other mints. And so like from a primitive standpoint, this is basically like saying, okay, these are all things that can create new coins. But once we get into kind of the programmability aspect, these mint outpoints can be controlled by script and by contracts. So the mint outpoints are kind of control structures that we can build into more complex systems that build on top of this. Then we also have the concept of burning tokens, and I did not finish my example here correctly. So essentially, when a mint is spent, any tokens that are on the input side of things with it are considered burned. And any tokens that are created from it, so any tokens that appear in the output are considered minted. And so, and this really unlocks some cool things where I'm going to go in the future with this. But it essentially allows you to restate the validity authoritatively of a set of tokens. So in a managed supply, if I've got tokens that maybe have well, I don't want to get into that right now. Essentially, it's a way of kind of putting the issuer's stamp on a set of tokens to burn them or reissue them or do whatever other operations that I'm not thinking of right now. But essentially, it's that burning and reissuing. So that's actually all there is to the token protocol. So validation, obviously, you need to be able to check back. But at any point where you have an output that has a token ID or a deploy outpoint in this field. So regardless of whether it was just deployed and I have one of the first outputs, or whether this token has been 53 million times and has gone all over the place, the output holds a pointer to where you need to validate back to on the chain to validate that this transaction is good. So because this outpoint simply comes from wherever this deploy output appeared on chain, so I spend that, and then that gets spent, and that gets spent, and every time on every transaction from that transaction to anyone in the future, every output will have this deploy outpoint in there. If it doesn't, it's not valid. If it does, you can walk back that chain to look at each transaction along the way, make sure they follow the legitimate transfer rules of let the inputs are are greater than or equal to the outputs, the value has transferred, and just by walking those things back to the outpoint that is defined within those outputs, you can validate the token. So, and again, as I mentioned, the whole point of this was, I'm really don't need to have that much stuff open on my screen. The whole point of this really is to look at token programmability. And on that note, I've got something really, really cool I'm working on. I want to give it a little more thought before I talk through it on screen, but I kind of wanted to get this background set up of here's the tools I'm using to think through token programmability in Bitcoin. I will probably pop one again sometime in the next day or two. Bye-bye.